All right, so we'll get started. Welcome, everybody. Thanks for coming here today. My name is Nick Farnell. I'm the coordinator of the Business Analytics Postgraduate Program. So before we get into the presentations, I'll just give a little bit of context, tell you a little bit about the program. I know most of us know about the program, but everybody watching from home, everything's up there as well. This 2-semester postgrad program is designed to build skills in using data to help inform decision making. And we have students that come from a lot of very diverse academic backgrounds, including economics, marketing, HR, law and customs, mechanical engineering, computer science. What else am I forgetting? Lots of great backgrounds. Next intake, we already have more than 600 applicants for 36 slots, so it's well done getting into the program and well done finishing it off. So students complete technical courses in data mining, predictive analytics, statistics, but also a lot of strategic courses in decision making and data ethics and a lot of other fun stuff. And this capstone project represents bringing all of that together. So these are real projects. They're not of the textbook. They're solving real problems with real industry partners. Many of you were here for our last set of capstone projects back in April of this year. And after those presentations, the final documents that those students submitted was a reflection of the project. And then one of the first assignments that this group of students did was reviewing that reflection. And then the last thing that this group of students will do is that reflection for the next group of students. I wanted to thank the instructors in the program, Alan Walsh, Lee Doucette, Zach Drew, Holly Kaiser, Alex O'Brien, and of course, Brian Long. I know there's a lot of questions for all of you, even for myself, after class time, so thanks for the guidance there. And I wanted to thank the industry partners who are going to learn a lot about a little bit. So the format of these presentations, about 15 minutes, give or take, and then we have some breaks in between. So the presentations themselves, they're fairly short, a quick recap of the overall projects. In some cases, there's some sensitive client data in the presentation that the student won't be shared, so if it seems a little bit short, then that's why. But still, please do ask a lot of questions. I know that the students want these questions. And if you want to see more about the projects, you can visit the website businessanalytics.niagaracollege.ca. I'm going to give it up to April for a couple more words.
Hi everyone, my name is April Turlow. I'm Associate Dean or Associate Dean in the School of Business and Management and Business Analytics programs in my portfolio. So just wanted to say congratulations on making it through to the end of your term. I'm sure you're really excited to wrap up this week, get your exams done, get your final projects in, go home, hang out with family, sleep. I don't know, whatever your plans are for the holiday break, but congratulations on completing the program. I know, well, I don't personally, so I can empathize, sympathize maybe is a better way to put it, how technical this program is, how it has probably stretched you beyond what you thought you maybe were capable, especially sitting in your class for the first time. And so congratulations for a job well done, and hope that the program is a rewarding experience for you. And thanks to Nick, he thanked everyone else, but nobody thanked Nick, so thanks to Nick. And to the rest of the faculty, the hours that they provide, the extra support that they give, the way that they are emailing you at potentially all hours of the day, supporting you and answering questions you've got, especially in this course as you're trying to create your project and your presentation and looking for feedback. They go above and beyond. I know that for sure. And so let's give all of your faculty a round of applause. If you've been looking forward to this day, all term, last year at this time as well, or not last year, since spring, as Nick had mentioned before, some really cool presentations. So super excited to see what you guys have created. And yeah, again, wish you all the best as you leave Niagara College. And if you're sticking around, I'm sure we'll see you. But if you're heading on, hopefully to work in the industry, we wish you all the best. And yeah.
So our first group is titled Predicting Student Success. And if you want to get things going, we're ready for you.
Okay, hi everyone. We're the one of the registrars groups here today using the registrars data, and we're here to present predicting student success in their college. And so this is our team, starting with Joanna.
My name is Joanna. My name is I'm from Colombia. I'm a psychologist. I have over 4 years of experience in human resources. And yeah, that's about myself.
I'm Paula Pinilla. I'm also from Colombia. I'm 26 years old. I'm a mechatronics engineer with 3 years of experience in the industrial automation and energy saving projects.
Hi, my name is Pilambi. I'm from India. I'm a commerce graduate and qualified chartered accountant by profession. In past, I worked in few Fortune 500 companies. My experience lies in financial accounting, reporting, auditing assurance, and transitioning process. I would like to thank April for giving me an opportunity because she appointed me for an accounting tutoring hub. So thank you for that. And yeah, now I'm in business analytics program.
Okay, hello everyone. My name is Ishmi and everyone call me crazy. So every time when I introduce myself, I always say that I'm a mom. So I almost forgot what I used to do. So I came from China. I used to be a financial professional, and then I decided to pursue an MBA. Then I go to Prague. After I graduate, then I shifted my focus to take care of my kids. So last year, I decided to re-enter workforce. Then I'm glad I chose Neva College as the starting point to the new journal. So that's why I'm here.
And I'm David Lisi. I'm from Niagara Lake around here. I'm a pretty well-versed professional in investing, economics, and entrepreneurship, as well as various analysis. And yeah, in the program as well here.
Okay, so everyone here is very familiar with Neva College, but please allow me to introduce once more. So Neva College is a leading post-secondary institution in Canada. Also, we're located in the heart of Neva region. Neva College offers more than 130 innovative programs. I'm also the Canada leader in applying and integration, and our graduates possess control and the global competencies. So our client is Neva College's registrar office. So office handles admission, course registration, academic recourse, and the graduation processes. We would say registrar office plays a crucial role in supporting students throughout all the academic journey at Neva College. Let's take a look about our schedule. So our whole project is divided to 5 stages. The first one is we met with the registrar office. Then we, our team did data review. Then we did data cleaning and data analysis. Then we built up our dashboard and the model. At the last stage, we wrote our report.
So we proceed further with the project overview. We have a project objective and scope, data collection, cleaning and exploration, model building and validation, and finally report finding and the assessment. So let's get started. What is the objective and scope of the project? The objective of the project is to build a predictive student, build a model that will predict the student's success based on different demographic variables, and also this model will help the college to analyze the student data and help in decision making to guide future research on the subject.
And so ethical implications were something to take pretty seriously as we're dealing with student data, and especially because we're students ourselves, seeing the marks of other students does present a pretty serious ethical breach. So to prevent this, what we first did was we all signed a non-disclosure agreement, so we're not sharing any findings or information that we find about us or other students or really anything about that. And beyond that, Professor Nick filtered the data so that instead of having student numbers, we had synthetic IDs that replaced those so that the depth of information couldn't be carried any further beyond.
Now going deeper into our project, we have here a little summary of the tools that we use during this project. So we start with Microsoft Excel, which is where we have our main data sets. So Restart Office shared as an Excel file, and from there we did our first cleaning, data cleaning. Then we went to R Studio and we realized exploratory analysis and also some statistical analysis to see an overview of how Niagara College students from those specific terms that we're going to talk a little bit further were performing in general. After that, we worked to Power BI. As you can see, we use this tool to be our main dashboard, and also to build some graphics that were going to give us some graphical analysis to understand much more the data that we were having. Then we use RapidMiner, which is a software that we saw in our data mining program. So we use RapidMiner to build our model itself. So in this case, we built 2 models, and then last Canva for the purposes of our final presentation.
Finally, we received the data from the college registrar office, and we wanted to first review and see the quality of the data set. Then we did an initial exploration of data in Excel. Data cleaning was the first stage where we filtered, sorted, and removed all the duplicates. Then we merged different files into a combined data set. We did found some NAs in the data set because there were few students who did apply but were not enrolled in the course. Then we filtered the data and we found that there were 29 rows and 8,748 columns. The data included mainly the synthetic ID, the campus, the term of the school, the student, whether the student is international or domestic, the school in which the students are enrolled, the GPA and standing. Then to understand the relation better between different kind of variables, we also built a correlation matrix to identify the main attributes which would be required in the modeling stage. Finally, we built a predictive model based on the targeted attributes, and finally a Power BI dashboard was designed to understand and analyze the trends and patterns of the data. So this was the initial data analysis that we found. 53% of the students in the college are female as compared to 47 male. The international student population is, of course, more than the domestic student, like international taking a range of 60% of the total population. The most popular school in the college is School of Business Management, followed by School of Nursing. And finally, we understood that students falling under the age bracket of 32 to 40 had an average GPA of 81 as compared to the domestic students.
Moving forward with our project, we have here the methods and analysis that we have. So as we previous heard my colleagues over here, we did the main data set. We built this correlation matrix that basically was turning our categorical data into numerical dichotomous data. So we have those specific points to see the relationship between all the attributes that we have in our data set and the relationship with the standing, that is like our main attribute right here. So from this correlation matrix, we get to these 5 attributes over here that are the credential, the type of student, whether it is domestic or international, the age, the school of studies, and the gender. So those main attributes are discussed and plotted here in our main dashboard. So as we can see, we start. First of all, it's important to give you an overview of the data that we have. So we didn't have all the information of the Niagara College students. We just had the students that were enrolled on the first level for the terms of fall 2022, winter 2023, and spring 2023. So from there, we get to build this dashboard. So we have here in this first area, the main graph that is going to show us the distribution of the students and their standing in overall. So we have here that most of our students are in a good standing. So from the 8,700 that we have, 6,800 are in a good standing. So as per the policies of Niagara College, we can see that this good standing means that the students have a GPA of 65% or above. Then for our students in honor, that is just 1.1 thousand of students, these were students that had a GPA between 50 and 64%, or they had 65% GPA, but some had some courses missing. Then for our probation students, so these students had a GPA between 40 and 49%. And then last, the academic dismissal that is also contemplated in our project, that are students that had a GPA below 40% or were in probation for 2 terms. Then from there, we have also the age, the gender, the distribution by school. So we have here all the schools that are part of Niagara College. The students type by international and domestic, and here this card that is going to give us the average GPA of the students depending on the victory. So this dashboard is a dynamic dashboard that we can use the different filters that we have here, which is by campus, by credential, and by program. It's saying that, like if I go to the Niagara on the Lake campus, we see how all the data changes. And we see, for example, here a variation on the GPA, which is not that much with the one that we have in general. But we can see that Niagara on the Lake campus has just 5 different schools of studies. Now, if we go also in this and we analyze the online campus, we will see a considerable change in the average GPA. So this is the first part that we can look as a finding, saying that maybe Niagara College should start reviewing a little bit the performance of the online students because it's evident that the engagement and the performance is not as good as the in-person programs. On the other side, we also have a filter by credential because, as you can see here by the policies, the credentials are different. So we're going to pay 5 different credentials that vary on the number of terms that every credential has. So, for example, the baccalaureate degree is going to have a semester, while graduate certificate in business analytics is just going to be 2 terms. So that might be also a point that might affect or make a difference in the performance in general because, for example, we with 2 terms have less chances to improve, or we have more chances to see the difference in the percentages. But with longer programs, it would be like a moment that they can stabilize. And on that, if you want to also see specifically by program, we have also that filter over here. So we can go to the business analytics program if you want, and we can see our performance. Maybe we can just continue, and then after I can show everyone.
Okay, so now we're going to be talking a little bit about the model itself. We compare different models in order to be able to find the more efficient for predicting the student success. In this case, we decided to move forward with 2 of them, that is in an decision tree. So just to give you a little bit of overview. Here we do have the explanation, but just to give you a little bit of overview how they work. So for example, the KNN, what it does is let's say that this is the one that we want to predict, and it's going to look at the, in this case, three nearest neighbors to be able to predict this one based on the results that it has on the information that it has in the other ones. So that's how the KNN is going to work. And in case of the decision tree, the thing that we're going to see is that we're going to be having here, like the first attribute in our case is going to be age, and then it's going to start like dividing into the branches itself, and until it gets to the prediction that in this case it's going to predict if it had a good standing or not good standing. So what we did was we grouped the not good standing, like our reprobation and dismissal, into not good standing to be able to like do the forecast in this sense. So here what we're going to see is like the statistical analysis itself. So as we like mentioned at the beginning, we did a correlation matrix based on like all the factors that we had in our data set. And these are gonna be the percentage of like the correlation for each one with standing. So we have the 5 different factors that are floating into the model itself. So just to give you like a little bit of overview, the decision tree, like we compared the two of them, and we're going to be explaining why we took two models. So regarding the decision tree, it's going to have an accuracy of 77.19%. That it basically means how accurate is the model predicting what it has to predict. What we did is we split the data that Register Office gave us into two parts, 70% to train the model and 30% the decision tree has its 77.19% with a standard deviation with an error margin of 1.04. That makes the model stable. And an important thing to take here into account is that like, this is going to be how good the model predicted as good. So it's going to have 97%. And this one is going to be how many not good it predicted as not good. So here is where we have like the main reason why we decided to move forward also with the KNN, because in this case it's going to be just 5.72%. That is not as high as we would like to. But regarding the KNN, even though it has like a lower accuracy, it goes down to 74.48%. With a similar standard deviation, in this case, it's going to be 1.30. In this case, the important thing to take a look is this one. So the true good, it's going to be 88.80. That, if you can see, is a little bit lower than the first one, but the big difference is going to be here. So we passed from 5% to 24%. So kind of like 19% goes up with the KNN. And also, we want to explain why these results, some of the limitations we saw during the project itself, and the challenges and limitations. We consulted different articles in which we could like conclude that there are many different factors that can affect the student success. For now, on the data that we were working with was the student demographic information. So as it has been mentioned, was age, program type, etc. But we're not taking into account the other factors that can be affect the success itself. So in the second one, it's going to be private academic achievement. We do have some of the GPA from high school for the domestic students, but as we saw in the dashboard, in our college, most of the students are international, so it was not a representative sample to be able to work with that one. The e-learning activity, that in this case means, for example, how many times the student logged into Blackboard, how many assignments he performed, the quizzes, etc. Like every connection that has with the e-learning platform. The psychological attributes, so let's say, for example, how each person manages stress, anxiety, the self-motivation part, and also the environments that it refers to the semester duration class that we do have that information, but as Paula mentioned, we are just taking into account terms, and that makes the work not like a time-based study to be able to consider the environment as well. So the next steps is we will recommend considering the different factors in case that this project has a second part. And also if we can add like some information about career success. So let's say occupational status, salary, like career satisfaction and everything that happens before the student graduates. We also got to know that Niagara College has a committee that is called Academic Affairs and Strategic Development that is actually focused on like providing activities like on track to get to student success. And an important thing here is to see also the members of the committee because it has a representative of each of the different areas that it can give us a good insight. So like what we recommend is to start collecting the data of each of the different departments. And in this case, we can plot it into the model. It will have a higher accuracy, and also we're going to be able to start plotting all the factors for the student success itself.
Thank you.
Thank you.
So we'll take some time for questions now. I'm ready for questions.
For the presentation. We like everybody is I'd like to ask each person, each team member, that's the most interesting part of the whole project. What thing you didn't expect yeah, really enjoy what part, really enjoy what this facts.
I guess I'll start. I really enjoyed working with my group. It's very interesting for me to being part of this program. Like it's pretty obvious I'm the only domestic student here right now, and meeting even in the groups that we met throughout the semester, it was awesome working with everybody and really like made me think of all the different strengths or lacks that I have. For the project itself, it was actually really interesting to see. Even though the data is like limited, it was crazy to see how far we could go with it, and the insights that we got from it was. I'm still kind of impressed by it. Really happy.
For me, the fact that we really use this project to apply every like tool and knowledge that we have acquired during this program. So it was very interesting to just concatenate everything, even though just like small part of a tool itself. Like for example, R. We know that R has like a lot of things to explore, but we just use it in a basic way to do the statistic analysis. But like we work with that, and now we have some more knowledge than before. So applying everything into this project was very interesting.
I would say that on top of that, like we could apply like all that we've learned, like to the course itself, also the results that we had, like being able to have all the information in just one visualization and being able to work with it, also to like grasp some insights about the general about the college. It was like a really good project to work on based on like the information we had and also online and everything we learned.
I think for me it was more like I usually do individually, but now getting into a team, we learn so much from each other. I initially thought that only Excel is a good tool in which you can do some exploration, but then we did found like data, RapidMiner and RStudio is also one of the good software that you can explore and use in your professional life going forward. So I think that's the side that I have.
Okay, so for myself, I think the best thing is we apply all the theoretical knowledge to the practice. And the second thing is, and that's that, like back to school. Yeah, it's so happy to meet everyone here. So we have the lovely classmates and the knowledgeable professor, and we work with our team. I really learned a lot. It's maybe something not about like the knowledge or it's like a theoretical thing, but I learned everyone have a different personality, and we work together and learn from each other. That's a fantastic. Yeah, that's what I learned from the whole project, also the program. Thank you so much.
Any other questions? No other questions? All right, thank you very much. Well done. So this next project is a company called Bright Nights. They're a small company based out of Barrie. They do a lot of landscape lighting, kind of owner operator. You'll hear more about the project, but one of their big things is trying to better understand their target market and better ad strategies as well. So whenever the team is ready, I'll let them take it away.
You could start using
Good afternoon, everyone. Welcome to our project presentation. This is called table cooking. In this, we can see the main topics that we are looking at. So let's start. On the beginning of the term, our clients come to us to improve the marketing strategy by using business analytics, data analytics. The important thing or the relevant thing of our project is that we use we are gonna show how with a little data we can create or make a big impact in the company. Our team members are composed by Tad, Abe, Valeria, Catherine, and Ravi. Our partner or client work in installing lights, permanent lights, and events lights. For example, Christmas lights and Halloween lights.
Thank you, Captain. Hello, everyone. Now I'll be talking about the first part of our project, which is data gathering and analysis. Basically, our client provided us with their customer data set that contains the city, the job date, the job type, and the addresses of their customers. And as you know, our client is a small company. They started their business 1 year ago. So they were able to reach 71 customers until that time, which is great. But for us, it was a small amount of data. So in order to expand it, we transformed each address to 122 census data point. That goes from the average household income to the average number of food inside the household. Then we separated our data into two parts. The first part, which is the customer data that we already talked about. And the second part, which we would like to call the regional census data, which is basically all the streets and addresses of the business area. Then we did the same thing. We transformed each address to 122 census data points. Now, we have a good amount of data to jump to our analysis phase. Here, I don't want to sound technical, so I'll go quick through it. Simply, we have used two models, K-means and K&M. These two models help us comparing between the characteristics of the addresses of our regional census data with the characteristics of our customers' data. And as a result, we ended up having this table that contains the regional addresses and the distances. But here, I want to make sure that you guys understand what distance means. It's actually not the physical distance, but it's more like a score. So to make it more simple, the smaller the address is, the smaller the distance is, the more similar the address in characteristics to our customer database, which means the higher potential customer to our client. Now, my colleague Valeria will be talking about it more after the slides. Thank you.
Everyone. I will back to what my friend just said. You can see here different addresses and different distances. The shorter distance, as you can see in the first row, means a higher likelihood to have potential clients, and a higher distance means a lower likelihood to have potential clients. So the data from this table we transpose into a heat map. Here you can see that area that's shaped in the purple color. It's areas that we should focus on, and the areas that are the red color show us areas that we should avoid. So next slide shows us quick characteristic of those models. As you can notice, the southeastern area compared to northern area are characterized with a lot of purple color. So it means that it has a high likelihood to have potential clients. So to be concise, we should focus on the southeastern area, target it first, and test our model. Okay, here we found some interesting patterns. As you can see, around such small red condensed area, we see a lot of purple color. What does it mean? It simply means that such small red condensed area might characterized with such industrial buildings, townhouses, and apartments that will be not profitable for our company. And as a small conclusion, I want to say the first thing that downtown areas, the downtown area seems to be less likely have a lot of potential clients there, which in fact makes sense. And also, I want you guys just keep in mind that by using these charts, you can simply say which area we should focus on, the purple one, and which area we should avoid, the red one. So that's the basic characteristic of this chart, and now we can move further to our next charts with Abhay.
After this, I want to draw attention to client insights, in which we're going to compare characteristics of non-customers and customers, and I'll show you there's a trend in customers and non-customers if you compare them. First is income. So this box plot shows that customer data has a higher income than non-customer data. If we move to next graph, it's median age. If customer is much older than a non-customer. Now, to summarize all the characteristics, I want to show you like marriage rate. Our customer has higher marriage rates family, they are family oriented, ownership, of course they own the house, household income, they are earning much higher than our non-customers. Age, as I told you, they are much older, and education, they have a higher education. Next, as Ravi and Valeria said, that there is distances scores. Higher is least favorite, and the smaller is most favorite. Now we would like to depict all these scores with Google Maps and photos to show you how they look like.
Everyone. Now we're going to talk about the area analysis because we don't have positive and negative data points. We only have neutral and positive data points, meaning that we have customers and non-customers. By non-customers, it doesn't mean that that person cannot be a customer, potential customer. It just means that person is the general representation of the population in the business area. So it's very, very, very hard to test these types of models here. The way we did it, we just transposed all the addresses, the top addresses here, as you can see here, and the least favorite addresses, and try to see with our own eyes if there are any patterns that we can focus on and test our models that way. First, we're going to talk about the least favorite areas. Industrial areas. As we can see here, there are a lot of businesses here, and these seem to be the least favorite areas that are picked by our model. These types of companies tend to work with more established contractors. Our company has been working for only 1 year. Their reputation is very good among their customers, but they're not very established in the area. Second one, townhouses and apartment buildings. As you can see here, we have a lot of townhouses, some apartment buildings. These have a low rates of ownership, which is not good for our customers. Our customer base are more of a family. They have a high rate of ownership and marriage rates. These type of areas or these type of buildings seem to be owned by businesses in general. As we can see, as we've seen before, businesses tend to work with more established contractors. Finally, low maintenance. As we can see here, the roads are not maintenance. The maintenance is very low. The backyards too. What that means, in our census there, we can see how much a neighborhood spends in maintenance in general. And this is picked up automatically by our models. Let's go and talk about our most favorite areas. Family friendly. We talked about how marriage rates are higher, how they have more kids, and more number of rooms. As we can see here, we have a basketball net and some family decorations. The first addresses and the best addresses all look like this. And we just picked that up using Google Maps, which is very good, honestly. The second one, large property surface areas, plus higher maintenance. Looking at both these characteristics, see that we have large backyards and they are maintained. That's one of the key points of our model that's been picked up automatically. Recommendations. First, we have different types of targeting strategies. Are you going to use Google Ads? Are you going to use Facebook Ads? Are you going to use flyers? One of my recommendations personally, use flyers first. I use different types of CRM tools to go ahead and build an ROI projection for each of the models in order to test it. The second one is customer segmentations and impact. Because we only have neutral labels and positive labels, we would like, in general, to have negative and positive labels in order to test the model and make it better along the way. The third one, technology integration and efficiency. I worked as a contractor before in my hometown, our country. What I used to do is use technology to integrate more and more models automatically with time. Our model right now is static. By static, we mean that we only have 71 customers that we're working with. Right? This was we built this model 3 months ago, and by this time they probably have 25% more customers because they're just a small startup and working fast, getting more and more customers each time. And what we'd like to suggest is for them to use different CRM models and different analytics tools in order to build an automatic integration tool in order to get more and more precise results in the future. And the last one is financial implication. With our models and our data, we can do so much, but at the end of the day, we should focus on one key point, which is probably for a company profit. If our models don't make sense using in ROI, if it doesn't make any sense, then they should not be used. That's why we suggest for our clients to use different types of ROI projections and predictions in order to get their models to work perfectly for their business cases. Thank you very much. This is the end of our project. Will you have any questions?
Not a question, but just very good presentation. Love the little heat map. I'll be really interested to hear like what the Bright Knights do with the data, because what you guys did for a small company is very valuable work.
Exactly. Thank you very much for your question. Basically, what the presentation is all about is that I used to work as a contractor, and so my friends did too. We always had companies come to us and say, "Okay, I don't have that much data. I only have the addresses." I'm like, "Okay, that's a great start. You can get so many key points. Certainly, if you're like in Canada and the US, you can get so many census data from only an address." And exploring these type of metrics that we have now, these type of modern tools, is a great way for a company to get ahead of the competition in general. So that's one of the key points I want to make for this presentation right here. If you're a small company or start a small company, with the tools we have now, there's so much you can do, so much potential to exploit or to use to get ahead of the competition in general. So that's the whole premise of the presentation. Thank you for the question.
Okay, I got one short question. Can you talk a little bit about how you integrated StatsCan data into your model? Like, what tools did you use? How did you get it?
Customized. I used to work as a contractor in software engineering, so I used an API from. Basically, a company gives me 1 month free to get as many census data as I could. I did it in 1 day, took all the data, and said, free trial, I'm going to use it, And we took all the addresses of the customers and all the addresses of the region area and transformed them into census data at that point.
Python?
Yeah.
But the question is, are you just planning to share this model with your client, and also for sure the client is increasing in the future? So we do model using all the data itself and help find in predicting the customers.
We built with the help of our professor, built a 30-page report for the company itself. This is just a presentation here. There were many details in the report in order for them to build their own model and use our own model. But the most essential part is that we use all the regional addresses of the area and rank them by distance, which means the smaller the distance, the more likelihood to have potential clients. And they have the table sheet of more than 600 streets and 600 addresses, plus the graph, heat map we showed you, so they can explore that on their own. We gave them a lot of good advice on how they can integrate that technology, and we can stay in contact in order for them to integrate that perfectly. Yeah.
The data that you received from the client, did you find that the client, the customers had been clustered quite well, or was there a very broad variety of the data points?
The technical points, we didn't want to go to it very harshly, because I know a lot of people here are not very technical, so we would like to make it as simple as possible. But I'm going to go through it now. We use both the k-means and the k-net. K-means, in order to cluster, they're into multiple clusters. I mean, yes, you're a company, but you have different types of clients. We find 5 general or more representative clusters. And we use each cluster, we compare our new data points, which are the original data points, to each one of the clusters, and the smaller distance is the distance you see in the table sheet. So yes, we clustered or segmented our data points we had for our customers. We had 5 types of flights, and for each new data point, we compared that in distance to each one of the clusters, and the smaller one is probably more likely to be in that type of cluster. That's a great question.
Any other questions? All right, thank you very much. Very well done. Fair. So we have a few minutes till our next presentation. Our next presentation is actually another college client. It's natural language processing. So this team is working with institutional research to look at survey responses. When you think about survey responses, you're ranking something 1 to 5. It's fairly easy to process that. But when we're looking at text data, so all of the comments that come in with these thousands of responses, it can be a little bit challenging to process all of those. So this next team used some natural language processing approaches to be able to categorize and predict the sentiment of some of these comments. We'll give them a couple minutes to get set up, but then at about 2:40 or so, we'll get started on the next one. All right, I think we're ready for the next presentation.
Hello guys, my name is Hani, and today we are presenting on text analysis on NC surveys. So before we start this presentation, I just want to ask you one question. How do you guys feel today? Most of us are anxious, right? Because of our pending first group, and this group must be feeling pretty relaxed because they are done with their presentation, right? What are these things? These are actually the sentiments or the feelings that humans only have. You can feel sad, you can feel happy, you can feel anxious, or you can feel relaxed. So the only difference between us and the machines is like machines cannot feel. They can do coding, they can do cleaning, they can do many things. The only thing that they cannot do is they cannot feel anything. Okay? So this is the biggest difference between humans and machines. And as Dick has already explained to you guys, that Niagara College has been conducting surveys from a long time, and they are actually able to interpret all these surveys from these surveys. And if you check this part, so here we have two types of questions. This is the rating scale in which we talk about like how do you feel? Are you satisfied with the college services? Are you satisfied with the college program? Are you dissatisfied? Or what are you feeling? So these are just like normal like rating scale. So here the computer what computer does is it just assigns values to these things. 1, 2, 3, 4, 5. Computer is able to read the numbers pretty easily. It can work with numbers pretty good, but when it comes to text, it cannot actually read or judge the sentiment or what you guys are actually talking about. All right. So So before I proceed further, I would like to introduce my team. It's Sani. Here we have Kay and myself, Honey. All right. So right, now let's talk about the model. So I've told you that what challenges these machines face. So how we actually train these machines to actually read these texts and judge the sentiments and the categories of the video comments. So for this purpose, we have used the natural language processing. We're going to run a short video through which you can actually understand what is natural language processing.
Star Wars fans would be familiar with the golden life-size hospitality robot C-3PO. While Star Wars might be set in a galaxy far, far away, the reality of having machines talk and respond to us in a human-like manner is already a reality, which keeps getting more and more realistic with every passing day. The people you ask for queries on websites, your smart assistants, even calls made over the internet, all of them have one thing in common. None of them are actually human. Now, you must be thinking, if they're not human, how do they manage to sound and seem so human-like? How do they respond to me so intelligently? And how are they so articulate? This, my friends, is the magic of natural language processing. What is NLP? Natural language processing, or NLP, refers to the branch of artificial intelligence that gives the machines the ability to read, understand, and derive meaning from human languages. NLP combines the field of linguistics and computer science to decipher language structure and guidelines and to make models which can comprehend, break down, and separate significant details from text and speech. Every day, humans interact.
Okay, so I hope you guys have got the idea what is NLP, and it's actually artificial intelligence which we have used actually to interpret the results from the text part of the service. So next part will be explained by Kay.
So what's our model is going to categorize the comments. So the model will be for certain keywords. So like have like it's 9 categories about the school. So I like category about professors, category about facilities. So the model identifies those keywords from those comments and then categorize those comments into the particular category where it falls under. And then in the model, we also use sentimental analysis that will identify if those comments are actually from a satisfied student or the person is complaining or has some areas of concern. So that's what the model is going to do. So the project roadmap. So first of all, we had a meeting with the Niagara College Panel and Research Team where they gave us the data, on itself out, and using Python, we explore different libraries in Python to process those survey data. We tried Affin library, but the Affin library wasn't efficient because it was scoring those comments. It picks up positive words in the comment and then it gives a score to that comment. So it wasn't efficient. So we tried another library like 9base. That was what we used to train the model to build the model. Then we tried regex. So what regex does is for the categorization. And after which we wrote the code on Python. And the Python, when it processes the data through the model, it gives us an output in an Excel file which we uploaded on all the our final dashboard. After which we made a things for the validation and then we get our final reports. The tools that we use on this project, we use Microsoft Teams, also we communicated and shared our data. And in Python, we use it for coding and building the actual model itself that we automate processing of the data. We use Excel in collecting the data for the result of Python. And then Power BI for our dashboards to create insights on the survey data that we process from Python. And PowerPoint and Canvas was for our presentation and then our final output of the United States. So sorry we're talking about the progress workflow and how we were able to keep the model on.
Hi, talking about our project workflow. Niagara College usually conducts surveys on a platform called SurveyMonkey. So SurveyMonkey is one of the popular platform which is used by the corporates to conduct the surveys. So all the responses we are giving in this survey are going to store in a SurveyMonkey database. So what PED team has did is, so they have extracted certain attributes from the database and they have shared with us. So the attributes include the random ID and what the student is commenting, like what they are commenting, and whether the student is international student or domestic student, or which program he belongs to, which school he belongs to. So they have shared this information with us. Then we have after getting this information data, we started our analysis path. So first we started with our data cleansing. Since the data has been extracted database, the data is pretty clean. There was no null data, there is no missing comments, everything was pretty clean. Later we started playing with the data, like we explored various libraries to find the sentiments and categories. So there are things in front of us. One is, the first thing is we need to provide the sentiment of the comment, and the second challenge is we need to say what categories this comment will fit into. For suppose if someone is discussing, someone is commenting something regarding the teachers, or if they are giving the feedback of the teachers, so this model should automatically map this comment into the teacher's feedback. So this model should automatically map this comment into the teacher's feedback category. And also should say whether it is a positive comment or it should be a negative comment. Think about our first thing, a sentiment analysis thing. To achieve the sentiment analysis, we explored a library called Affin, as Kay said, but the accuracy of the model is pretty low. Like we are getting the accuracy of 60%. So we thought of giving up that idea, and we developed our own model by using naive-Bayes algorithm. So to develop this naive-Bayes algorithm, what we did is like we got 1,000 rows from PED team, and we categorized this data into training data and testing data. We manually trained 800 rows as a part of training, and we have given the input to the naive-Bayes algorithm, and from naive-Bayes algorithm automatically trained that, and it can able to predict the rest 200 comments, which we have given for the testing. So out of 200, we observed that almost 190 comments it can able to predict accurately, and 10 it was unable to do. And talking about our second part, categorization, since we have only limited data, we didn't get a chance to apply any of the model because there are 16 categories, but the data is of 800 rows. So this data does not fit us to the model to categorize the comment. So to address this issue, we used regex, which is a popular text analysis tool, which is available across any programming language, either Python or R. So we use regex to categorize the comment. So how we achieve it? So we have gone through each comment, and we have identified the main keywords that are being used to describe the comment. Suppose if someone is talking about the teacher feedback, the words that are being used is like professor, prof. The words that are being used is like professor, prof, teacher, instructor. So these kind of words are being used when someone is describing about the teacher feedback. So we gathered all these words manually, and we have written some complex regex patterns to extract those comments which are being discussed on the teacher's feedback from entire data set. So we can able to do that, and so by using regex and naive-Bayes, we have addressed both these problems, and finally the Python is going to result the output in the form of Excel file. The second one which you are seeing, the Excel icon. So if you see the attributes, you can find the sentiment and category are the two new attributes that has been created by the Python. Sentiment will say whether the comment is positive comment or negative comment, and category is going to say whether it is which category it will fit in. Finally, we are going to represent all the data in the form of dashboard, which would be easy for analysis purpose. So we use a Power BI to create a dashboard. This is an overview of the dashboard. This dashboard will help the survey administrator to know what has been happened in the survey. Like how many people have been participated in the survey, how many programs has been participated in the survey, what are the strengths and what are the concerns. So the data which you are seeing is completely cooked up data. Like as per NDA, we are not supposed to run the actual comments, run on the actual comments. We just cooked up some comments for the presentation and we are sharing with you. So the main features of the dashboard is 4 parts. One is they can see the overall performance, like how many strengths are there and how many areas of concerns that their students has been mentioning, and they can get to know category wise as well. Like if the survey administrator wants to know what are the positive comments that has been posted by the students, so they can drill down further from this. Like they can select on the negative and they can drill down further to see what are the comments that has been posted. So in this way, it would be easy for the survey administrator to drill down further across all the categories. And the third part is common words. These are the most frequent words that has been used by students in the program survey. And the fourth part is like you can find the overview, like how many people has been responded from horticulture program, how many people has been participated, how many people has been participated in business analytics program. So basically, this will give an entire overview to the survey administrator. Anil, you want to add any points here?
Okay, so the thing is, on these 4 charts, you can actually judge the overall performance of the college. So this chart tells you like how many positive and how many negative comments are there if we include all the schools, all the categories, all the residences. Okay, and this part is just showing you the areas of concern, like which categories should be should you focus on. So you can check how many negative and how many positive comments are there. In this section, you can actually check what are the most common used words by the students. Like if they're writing about a teacher, if they're writing about cafeteria, if they're writing about library, what are the most common used by them? And through these words, you can actually judge what they're talking about. And in this final segment, you can actually check like how many comments are there in each category or in each school. That is showing that part. But in case, suppose I want to check like in business analytics program, if someone is living in is an international student and want to check like what are they talking about, so you can actually select from here any program. You can select from here like which program they belong to. You can select business analytics here, and you can select here residency, like whether they are domestic or international students, and you can also select school and then the categories further to take a look into this. So this is the dashboard that we have, and yeah, so that is all. So this is the model that we have made for the text analysis on the NC surveys. You can also use the same model for getting feedback of the customers. Like suppose you run a business and your customers are posting your reviews on the Google or on your website. So you can also run this model on your website or on the Google reviews to check what people are actually commenting. So it's it's a very useful model which can be used at various platforms.
So with this model, every time developer conduct the survey, they don't need to go through it. Walk the manual to know what students are talking about. We always go through this model and to give insights, and then upload the Excel file and the Power BI dashboard, and it's refresh of the model to give insight on the new data. That was the model.
So that's it. Thank you.
Any questions from the group? What was your error rate?
Our accuracy is 85%, so error rate is more than 85.
Okay, I got two quick questions for you. One, this was a great project, but this one was interesting because you trained the model on the data that we had, and then midway through the project, the research team said, "Hey, we have new data. Do you want to try your model with this new data that the model has never seen yet?" Do you want to talk a little bit about that? And then the second follow-up question is, how many hours do you think you've saved the research team with not having to go through all of these comments manually?
Okay. So the thing is, when we got the new data, we have already tried this model on the previous data. So when we checked this model with the new data, we again got more than 85% of accuracy because we went through almost 150 or 100 commands to check whether it's giving us the correct results or not. And talking about the second question, yes, it's actually going to save a lot of time for the survey team because survey team has been actually reading one command at a time, like they are doing it manually so far. So they don't have to do it anymore in the same way. They can just simply upload the file in our model, and our model will actually give them the result, what are the sentiments of students and in which category each comment should go. So it will be really easy for them. They don't have to continue hiring more people to read each and every single comment. So
rather than analyzing the comments, they can use their time on some other aspects. They can feed the input to this, and this model is going to predict each comment whether it is positive or negative, and also the category as well. So from the dashboard, we can see what are the main areas of concern. So the survey administrator will show to the same thing to our vice president or president. So they can respond positively on that. So if you consider the previous PES survey, since we have gone through each and every comment, a lot of people have complained about the pass passes. Now Niagara College has provided a free pass to each students.
So that's how it can help. Yeah. You can actually see in which category people are complaining. So suppose someone is not liking the library. So if out of 800 students, 600 or 500 students are actually talking about the library, so they know. They can just take a look at the dashboard and they will know that what's that particular area in which they have to improve something. So it will help college in improving their services, and it will also help them in learning the overall performance of the college.
So while carrying out these projects, the data they give to us initially had 900 columns, and it took us time to train that model because we had to manually pick the keywords and identify it. But when the college gave us new data, we ran it through the model. It came out within seconds. It made those categories very fast. So the comments we're talking about 2 things or 3 things, and it will identify for this comment mentioned teacher or bus pass or facility. It indicates that these keywords are in this comment, and it puts that comment in those categories as well. So it's very fast and it will save the college a lot of time. So each time they get new survey data, they run it through it comes out very fast and it's accurate.
Yeah, so in simple language, if someone was taking almost 8 hours to read all the comments, now he can do it in 1 minute. Just upload the data and ask him it shows you the stuff.
Yeah, really interesting presentation. I like how just even based on what you've seen so far in the other ones, even ours, what you guys did was so different in the sense that you're analyzing the text instead of numbers, right?
Yeah.
And even in regards to the ethical implications, we're dealing with student data, same with you guys can't even show us your work plan.
Yeah.
Right? So it's cool to see that, those kind of things working and everything that's going.
Yes. We have to make sure that you guys can actually see that because there are things.
Great. Any other questions? Well, thank you very much. So population and housing is up next at 3:05, a couple minutes to get set up.
doing it.
Yeah, if you're ready.
Okay. So good afternoon, everyone. Today, my name is Julia. Today, I'm here to talk to you about my project, which is Canada Population Growth and Housing Supply. This is today's agenda. So I will start explaining you a little bit about the project objective and scope, the team members. The problem statement for this project was that we all know that Canada is experiencing a significant growing population, and we also know that the housing market is not aligned to the demand nowadays. So the objective of the analysis is to analyze and evaluate the impact of Canada's growing population on housing demand. The focus areas for the project are trends in housing and population over the recent decades, specifically the last 20 years, and then the relationship between population growth and housing demand. And the methodology that I used is the development of a linear regression model with the analysis of historical data to forecast the future trends. But before moving forward, let me present you the complete team. So of course, there is me, Julia. I'm going to talk to you a little bit about my background. I'm Italian, I'm 33 years old, and I came here this year in April to study here at Niagara College. I have a bachelor in cultural and linguistic mediation. I currently speak 3 languages, and I also have a master's in European law and customs, and I will be soon a graduate of Niagara College. And I have 10 plus years of diverse professional experience that goes from customer service to graphic design, logistics, and IT and insurance. Then my partner in the project was Daisy, which is here with me. And she's just a small rubber duck. And I just want to ask you a question. Is any one of you familiar with the rubber duck debugging concept? No? Okay, no worries. So basically, with this concept, something that my husband taught me because he's a programmer is something that is related to programming. So basically, when a programmer is stuck somewhere with the code, he just takes a small inanimate object like this one, and he explains the code line by line. And this basically helps him giving like more view and more knowledge and understanding of the code, and also helps to like discover the bugs and find the solution. So basically, that's what Daisy did. She acted as a passive listener and helped me when I was stuck in the project. Moving forward with the project timeline, the project started basically at the end of October, so a little bit late, like a month later, respect the other projects. Before I was in another group, but then I decided to step back and to run my own project. And after that, so in this initial phase, I just decided how the project was going to develop. So basically, choose the data and take it from there. Then I went into the exploration phase, which involved the collection and the analysis of the data that I found. Then I passed to the cleaning part, but I tried basically to organize and prepare the data for the next step, which was the model application. And then in the end, I got today in the final presentation. The data sources for this project were Statistics Canada for the data on population trends, Canada Census for the data both on population and also on housing, and then the data on housing starts, housing under construction, and housing completion from the Canadian Mortgage and Housing Corporation. The tools that I use are the following. So I use Excel basically for data collection and exploration, then RStudio again for exploration and also cleaning, then Power BI for the dashboard, and Microsoft Word to write like the report, the project reflection, and so on, and of course PowerPoint for the presentation today. So, what are the main questions that came basically to my mind when I first started this project? So, the first one was, how did Canada population grow in the last 20 years? And again, In what ways have housing corporation and the market tried to respond to this increasing houses demand over decades? And also another question that I have was, how did like the major two events of the last 2 decades, which are like the 2008 crisis and the COVID pandemic, impacted on housing markets and population? So having a look at population historical trends, we can see that the population basically in the last 20 years just continued to grow. We passed from 31 million in 2001 to 38 million in 2021, which is good. And also if we take a look at the growth percentage, we can see that it was pretty stable, always between 4.5.7 to 6%, which is good. And if we take a look here, which is like a little bit bigger, at the two major events, one is here in 2008, and the other one here is the pandemic. We can see that on population, basically the 2008 crisis seems that didn't have like a huge impact. While for COVID, it's a little bit different because we can see that there was like a sort of like slight stop, but then the population continued to grow anyway. Having a look at the housing trends, we can see that also the houses available were more during the year. So we passed from 12 millions to 16 millions in 2021. But I want you to focus on the growth percentage, because if you see the growth percentage, like during the years, like it significantly dropped. And this led me think that maybe even if the houses available were more, probably the availability was less because the population was growing very, very fast and the houses were never enough. Now, if we take a look at house starts under construction and completion, here you can see it better. We have three categories. So we have housing start, which is the blue one, housing under construction, which is the orange one, and the yellow one is housing completion. So we see that, of course, like the trend was like going like ahead, so they basically continue to build through the years. But taking a look at the two major events, 2008 is here, more or less. Okay. And we see that there was like a significant drop after 2008, meaning that probably the housing sector was impacted by the 2008 crisis. While for COVID, we can see that it was like a little bit of contrary, because the trend, like after a stop, like the trend just continued to grow all the three fields, meaning that probably they use the COVID time to wrap up basically and go ahead to try to finish as many houses as they could. So what are the findings that I have after like the initial historical analysis? So I found out that post World War II, they collected an extensive database on population trend that is basically updated every 3 months. But I also found a discrepancy between the population data that you find in Stats Canada and the one that you find in Canada Census. And not because they take into consideration different like population, but because of the method that they use. So basically, they both take into consideration Canadians, PRs, temporary workers, and as well as students, and also refugees. But the difference is that the census is every 5 years, while the population trend updates every 3 months. But the main like difference is that in Canada Census, they consider not only the population, but also if the person had a primary residence or not in Canada. While for Canada, the Stats Canada, they just count the people without focusing on the fact that they have or not a residency. So the data like are different. And I found out, of course, that the two major events of the past 2 decades did not impact the population, but impacted the housing sector. And another interesting fact was that from the last 20 years of census, you can see that the average household size has always been around 2.4 people per household. Now I want to talk a little bit about the forecast. What is a forecast? So basically the forecast is the process of using historical data to predict future trends. It's commonly used in everyday things like weather forecasting, market trend forecasting, also revenue forecasting. And the accuracy of the forecast depends on different factors, such as the amount of data and the quality of data that you have, the method that you use for the prediction. Also depending on the variable, you can have like basically success or not. The model I decided to use for this project was the linear regression model. So I put the technical definition here,
but I don't want you to focus on that because I will try to give like a simplified explanation. So let's pretend that we produce ice cream and we want to sell our ice creams, of course. So looking at this image here, we have all these small dots that represent a different day of the year, and we also have two axes. So the horizontal axis basically represents the temperature, the everyday temperature, and the vertical axis represents the ice creams that we're going to sell. If you look at the line in the middle that goes from the left to the right, this line gives you the trend. So basically, the hotter the temperature, the more ice creams we're going to sell. And if you look also, there is an equation here at the top, and this equation, like the tools that you use to build the model, so this equation, and with that you can build the prediction. These are the results that I have from the forecast. So I basically, like here, I have the comparison between population and houses available for the next 5 years. So I took the data from 2021 to up to 2026. 2021 was the last year when the data were like most updated and completed. So that's why I choose that one. And I tried to go ahead 5 years. So if we look at population, we will see that the tendency is that, of course, population will continue to grow, and an estimation of 41 million people in 2026. Also, the houses will go up, will be more, from 16 million to 17 million. However, I want you to notice that the two lines, instead of like moving closer, it seems that they are going to divide more even. So this let me think that probably even if the houses available will be more, the population will grow so fast that anyway the houses available will never be enough. And if you think about it, now we are in 2023, the prediction dates from 2021 to 2026. And it's exactly the problem that we're having right now. There are too many people and we don't have houses. And the house that we have like cost a lot because there is no house. Looking at the data on housing starts under construction and completion for the forecast, we see that the tendency also is that the housing under construction will continue to grow. So probably they will try to finish like the houses. And also my thought is that also the housing starts will increase. So it means that they will try to start as many houses as possible because people need them. So the rate of success both for population, housing available, and housing under construction and housing start was pretty high on the model, 99% almost. But there was a tendency of like decrease on the housing completion. And this let me think that probably there will be some uncertainty about like how many houses they're going to finish. So for the findings of the forecast, what I found out was that the analysis, of course, predicted an ongoing increase in population over the next 5 years. And there will also be a rise in the initiation of new housing projects and construction activities. But despite the increase in housing starts, there is a projection of potential decrease in the completion of the housing project. And this can be due to several variables, for example, like lack of resources, workforce availability, mortgage interest rates that will go up or down, we don't know, government plans, and also changing in the political landscape. All these factors can impact the housing completion. Now I will continue talking to you about the challenges that I found in this project and also the future steps. So the biggest challenge that I had in this project was the time constraint because I started this project late with respect to the others, so time was against me, and it was hard for me to like meet all the deadlines on time. Also, data reliability and access was a challenge for me because working on my own on project management for the first time, it was hard for me to understand which data were reliable, which not, and also it was hard to decide what came and what not. Also, selecting the appropriate model was hard because we have, like, as you saw before, like we have a variety of forecasting models, which every model has its strengths and its limitations, so it was hard to select the right one. Then regarding the future steps, so for sure, continue to monitor the data is a recommendation that I want to give, and also maybe go ahead and do future analysis, also comparing with the results that I had to see how much closer. And then also another recommendation I have, inserting new variables in the analysis, such as the different house types that they are maybe trying to build, to see if they would focus more maybe on apartments rather than single houses or whatever. And also it can be interesting to go deep into the analysis, dividing the analysis by province and also by city, why not? And also taking into consideration government policies, because government policies can literally change everything, and so they definitely have to be taken into consideration.
Thank you very much. Any questions?
First of all, thank you actually, I must discuss this topic.
Yeah.
So, based on this, variables, any question is how do you think the model is reliable or you can predict that how accurate? The second question is, so you take for population and then
Housing.
yes, that
This one.
Why, yeah, of course, for you know, there's a lot of factors that impact on prices increase. One of the important interest rate, right? So because of that, at that time, the interest rate is so low, like close to zero, Bank of Canada policy rate was close to zero. So, like, then after they increase the interest rate, now you can see the trend of the housing like, dropping. In Toronto, in Sydney, in Niagara Falls, in Niagara. My question is, so what's the reason that you think like a big consideration of that kind of factor, like interest rates, the other factors? I mean, you take the population, like let's say, all based on the different size, right? Location, size, community background, is also the important factors affecting the whole housing.
Okay. So first of all, so let me see if I understand the question. So you want to know like the basically the success, like how successful it is. So I had, except for housing completion, I had 99% rate of success for all the other factors, let's say. So then after I said that, as I told like before, like time was against me. So basically, I didn't go like so deep into the analysis, considering all the factors that you mentioned, because I didn't have the time. Because it would have meant like collecting more, like spending more time to collect more and more data, and like spending more time on analyzing and cleaning and understanding. And I didn't really have the time because I basically lost 1 month. So that's the reason why I didn't do it. But for sure, it can be like a few recommendations. As I said, like focusing on the different houses type. As you said, like are they focusing maybe more on condos because more people can live in, or are they focusing on single houses? Like I didn't explore that because I didn't have the time. And also looking maybe the differences by province or by city. Like probably things are different like here other than in Toronto. So, but I just didn't have the time to do all this.
Julia, can I jump in? Can I jump in?
Yeah, sure, yeah.
So I get some insight because sometimes I get questions. So I'm explaining something to one of them. But among the main factors I'm getting these are the different areas that you can expand. So in my conversation with you, it's really let's do something together and then look at substance. prices, but also immigration policies and things. So there are, we are briefly and very quickly just give you an idea of the scope of this work. We identify at least 35 to 40 factors beyond just the pricing and immigration policies. Then we go to being a person of one, I am sympathetic and empathetic of
Also consider that like this is an estimation based on the fact that nothing bad, let's say, would happen. Like I didn't consider like another pandemic or I don't know, like a war or like some other major event that really can impact housing, population, and so on. So yeah.
But it's did you have that opportunity to separate population group by migration and fertility?
No, I didn't. I didn't have that. I just had like the population. I just know that they like the kind of status, let's say they count, but like.
So like with natural change, for instance, if you have some people on day one, 18 years ago, 1 years ago, new landed individuals, it's a need. So it does impact, but it's good. I like this. It's a good job.
Yeah, I mean that's also like one of the major, like let's say, challenges that I had, like regarding understanding that why I have a difference in the census and in the Stats Canada data, because basically for the census, if I don't have a house, and like I'm not gonna say that I'm not gonna be counted, but like they mainly focus, they just don't just focus on population counting, they focus on housing, they focus on household, they focus on a lot of things. Where population trend is just okay, this is the number of people that we have. So probably like if they run a census today and I am an immigrant with regular study permit, so I know that I'm gonna be counted anyway. But like in one case, I have a regular contract, so it means that I have my primary residence here in Canada. I'm probably gonna be part of the census. But if I end up being one of the people that maybe share the house with other 5 people without a contract, I probably be counted in the population trend, but I'm not gonna be part of the census. Like this, took me like a while to discover because it wasn't so obvious, especially in the beginning.
Trending is the
Yeah.
That's great.
Very well done. So we have a little bit of a break now. I think we have a little bit of light food coming. And everybody can get a little bit of a breather. Yes.
One is my little heads. So first for that, I would probably even look at what's linear model. And that would give you that trending point, especially for fertility. Because fertility rates are dropping, so that what's model rates, so that you don't maintain a linear regression model for the migration, and then we just make those make
Yeah, I look at it like honestly, like research like this, there are a lot of factors. Like for example, I regret that I didn't have the time to include like mortgage interest rate and that because they also impact. I mean, it's not just the housing availability, but like okay, maybe there are houses available, but I can't afford that. So this is also something to consider. But I just you could go on and on and on. Yeah, sure, yeah.
So you did a good job.
Yeah.
That's when they hire you for the job.
Yeah. Is that higher?
No, so what you do, I hope so.
Yeah. Oh yeah. They probably consider this part of their
So who do I thank for the food? Who do I thank?
Me?
Oh, thanks for the roll. Can you please do it again? Next time? Okay, good.
We had lunch last time.
I'm happy to do.
Good. I'm happy to hear that, Ryan. Just a few snacks.
So far, so good. So my area of expertise is it's home. Yeah. And also, I've never used any type of K models at all. So it's all yeah, but papers can be checked. Oh, they just don't. They don't want to publish it. They said it's like writing on different factors. So I'm exploring something because it's probably the most understood financial. Everywhere in Europe has anywhere between 58% So, and then of course that brings up some things. Well, because of the segmentation. I was having I know where I use Excel for that. I use SPS. Yeah, I'm just starting to get myself. But this is dropping. But it is interesting. So it's interesting because my initial hypothesis was because the kind of so the original policy was and what they would shock that and now we're trying to figure out okay but totally watch that you control so now you just start already to be the so what's the material? I really research right now see this stuff here. I don't like statistics of the area. Yes. I try to go down. Yeah. Oh, geez. You did right. Linear regression model. I only put that all around.
It's a slow progression. Jacket, collar, class, and then like we have 6 or 7 minutes. Okay, and also well, oh, he's not wearing captions anymore. Yeah, that's fair. So when I look at this, were you just saying? I look at and then I look at this is kind of for example, I don't see a second where when you're running the census, there is a risk that just going on the data without them. You know, the entire when you get the census data, there's like a cities that so I don't think of those things. I'm also to so for example, why is why no, thank you. I will follow. So you side. That was and it was a talk.
Like what is how you get a good job and how many acts to the house down and you can apply it. That's where I no, it is cool.
I will try.
No. This one.
All my life.
Okay, so.
I was gonna make I switch.
Oh.
I think you guys know I've never talked You're three of them. Tulu. Three of others. Isn't right. Ese vamos a hablar de eso.
Hey, so I hope everybody had a good little snack there. I think we're ready for our next team, which is another registrar's project. And I will let the team take it. Go ahead.
Okay, good afternoon, everyone. My team and I worked on this project, factors influencing student success in
Niagara College. My name is Ekene Wilmore. I have a bachelor's degree in philosophy from the University of Lagos, Nigeria.
My name is David Tiolani. I have a bachelor's degree from finance.
Kola Olioke, a bachelor's degree in statistics from the University of Nigeria.
Hi, my name is Varsha, and I have a bachelor's in electronics and communication engineering, and I also have a postgraduate certificate in position.
Today's agenda goes as follows. We're going to speak on the client's objectives, the project, the client project objective overview of data, technical concerns and assumptions, the tools we used while working on the project, the milestones, the models. We have 2 models during the project, then the findings, the limitations, and recommendations. Our client stroke partner was the Niagara College Registrar Office. The Registrar Office is responsible for everything admission in regards to students in the college. The project objective was to identify factors or variables that influence students' success in Niagara College. We're meant to analyze those factors and variables, then use those factors and variables to predict a model that will work long-term in predicting student success in Niagara College. This is our overview of that data. So we got the data from the registrar office, Niagara College. We got the data in 3 files. We have 3 intakes: the spring, the fall, and the winter. We had the synthetic ID. We had the date of birth, which was only months and year. We had the credentials. We had the school, whether it was the School of Nursing or the School of Business. So we had ethical. I'm going to speak on the ethical concerns and the assumptions. So the first concern we had was the data privacy. But those concerns were alleviated because Mr. Nick changed the student ID to synthetic ID. So he took out the student ID and switched it to the synthetic ID. He also took out the day in the date of birth and just left the month and the year. Then the confidential information, we have to make sure that none of the data that we were given was leaked. That's why we signed the non-disclosure agreement with the Office of the Registrar. I'm going to speak on the assumptions of the data. So while we assume that the data will be accurate, that every thing that the data comprised of will be relevant to the admission criteria, we also assume that there will be stability of external factors. I'm going to explain this stability of external factors more. So last 2 years we had the COVID. So students had to switch to online learning. So what we mean by stability of external factors, that isn't in play in the data that we got. Then effectiveness of support. We assume that we will have support from the registrar office as well as our project supervisor, Mr. Nick. Then we assume that there will be similar patterns in admission in the forthcoming years. That's whatever pattern was followed in this data that we are giving will be the same pattern that will be followed in the forthcoming years.
So for the tools that we used Microsoft Excel for the data cleaning, and for the exploratory analysis in the Excel, we use pivot table and charts. For the data analysis, we run regression and correlation. And for rapid miner, we try to build a model. We use decision tree and try the performance and accuracy outputs for the rapid miner. And for the Power BI, we give the analysis there as well, and did some visualization and created a dashboard. And we have PowerPoint for our presentation. So for the schedule for the project in September, we did data collection. That's in September through October. We did the exploration analysis, we kept going back and forth on the model we were supposed to use. And we finally found the model in the last week of October and the second week of of November, we had the modeling. Then in November as well, we did the documentation. Then last week of November and in December, we did the review. So for the data collection, we collected the data from the registrar's office, like Daniel said. We had 3 Excel files, mentioned that. Then the columns were altered for confidentiality. Then we had almost clean and organized data, which we worked with as well. Then the data dictionary was attached. Then for the data cleaning, we merged the 3 data together, removed the not available, separated them. Then we logically removed the columns, the student IDs and the dates and program which were not necessary. Then columns with missing information, like insignificant information that we didn't need, like the high school GPA, load that were not complete. So we took all those out. So shall we talk about that?
So I'm going to take you guys through the exploratory analysis. This is probably, I would say, the most interesting and frustrating part of the project, because during this phase, we learned a lot of things, and this phase, we experienced a lot of failures in the initial stage. So it was pretty difficult to get this mixed feelings right about the stage. So first off, we try to understand the data we're working with, the scope of the data. We saw we had 16% international students and 40% were domestic students. Then also the first gen. The first gen, they provided the first gen with just domestic students, so we couldn't have the that data set for international students. So the first gen was limited. So based off the chat, we could see that the not first gen had a majority because the data was not complete when it comes to international students. Then this is based off the academic standing. We have about 78% in good standing, while 10% are lapse and dismissal and probation. So this is the indigenous and indigenous and non-indigenous students based on the graph. We have the good ones, 66,704 good academic students, non-indigenous who are just 99 are in not good, and as well you can see that non-indigenous are majority compared to everything. So I'm going to show you the so this is our dashboard. It's an interactive dashboard where you could easily tell everything from the sliders you put here. You can see that if you go click on the good ones, you can see total number 6,803 good students and then started. Then you can go further. It breaks it down to the wider campus, the college campus, national students, domestic students, and also the general. So it goes down all around. As you could also get this out and go back to a lot. You can see it's interactive and it just brings out everything online the way it should have. We use slices, we use Mocha, we use five charts, stats, bar charts. We use the tree map as well. It also shows us the capability credentials, if it's on target, if it's the graduate certificate and advanced diploma. So I'm going to take you guys back now to the regression analysis. So after understanding the data, first thing we did off our bat was create the variables and throw everything into Excel to do regression analysis. And this was the result, R squared of 0.07, which is very low, that's about 7%. Initially, we had the highest, I think the highest R squared we had was 49%, but that was because we had the credentials, the cumulative GPA included in the variables to determine the good standing, which literally didn't make any sense because if we're trying to determine people who are going to be in good academic standing right from the application stage, they don't have a cumulative GPA at that point, so it won't make any sense to keep it out. We had 0.07. We tried as much as we can. We tried all the variables, different variables, we tweaked a lot of things, but we never got past, I think, 10%, which is very poor. So we decided to move far away from regression for a bit. We went down to correlation, which we probably should have done initially. So we decided to find out the variables that match, that correlates more with the good standing. So what we did was we took the variables, each of the variable with positive correlation, we took them and transferred them into a rapid miner, which we used to get more information about the data.
So I'll take you guys through Rapid Miner. Rapid Miner is a data science platform that uses advanced analytics and machine learning to use for predictive modeling. So we imputed our data, the clean data, into Rapid Miner and ran some analysis like that. As you can see, this is our process. We imputed data, then we filtered the data, cleaned it. We splitted our data into two. The 80% was the training data, and the 20% was the testing data. We did that. We set the role. The role is to predict the column where it's going to lie, which is the good standing or the bad standing. And we use our cross validation. Cross validation is to test the performance of the model. We use the decision tree. And our performance of the model got 96.1% in predicting good standing, but it was also good in predicting bad standing. And the overall accuracy was 4.2, but the standard deviation of 0.94. Okay. So while we're looking for other models to use, we stumbled upon boosted trees. I'll explain what reading boosted trees is. So let's say for five, over five, then it takes a shot at predicting a model, then fails, and is the next person. He takes the shot at predicting the model, but he learns from his mistake and try and make it better. Then I go next. So what really this decision tree is learning from each decision tree mistake to try and get the perfect one. And when you find the model, discover that the bad variable, the bad standing percentage went up to 3.13%, but the good went down, and the accuracy also went down, and the standard deviation is 1.84, which wasn't so good. We went to the limitation of the model. The accuracy for predicting not to was less than 10%, which I explained earlier. The group of most students under good academic standing, so the data was over 80% of students were good, and that few students in class standing. So we could not really predict the students with bad standing because it needs a lot of students. I think the data needs to be kind of before to be able to predict very well. And we discovered that it was difficult to kind of interpret the model for the decision tree and the good of over, let's say, 400. It was a lot, so it was difficult to extract them out. Yeah. So,
So 2 weeks ago, we had a discussion with Christina from the registrar office, and she made two things very clear. Her expectation was she wants to identify the students in not good academic standing so that the college can provide support to them, which exactly our model one was not doing. It had 8 or 9% not good students. Her second concern was if she gives us the data for the next year, she wants to see if each and every student is good or going to be not good standing. And that also was not achieved by our first model because it was just a model or the decision tree. So we came up with a form of a weighted average model. So first thing we did here was we had all the variables from our correlation. So this gave us a roadmap on what are the factors that actually influence the student's success. From this, we gave them weights from the correlation matrix with a few exceptions. So that's the weights given. The exceptions I meant are mostly for term and campus. So we observed that the September intake was a huge number, but also the correlation showed that the term was higher. But we couldn't give that much weight to campus, term, because it might distract the model too much towards campus. It might actually say that if a student is from the September intake, the student is going to be not good academic standing. So we had to reduce the weights on term and campus. So then we divided the data set to two parts, 80% and 20%. Each of the factors that we identified, we gave them a positive and a negative value. So how this was assumed is, for example, first generation and not first generation student. a majority was not first of the number in bad academic standing or not good academic standing or not good academic standing, and very less in number in the good academic standing, which means standing will be a positive value. I mean, not first generation will be a positive value, and first generation will be a negative value. Likewise, we did it for each of the variables identified, and dummy variables were created based on that positive and negative. And multiplying the weights that we already found from correlation with the dummy variables, we found the sum of weights for each of the students. And this way, we observed that the sum of the weights on an average was around 0.55 for students with good academic standing and around 0.75 for students with not good academic standing, which is considerably higher. And that's where we set a criteria that any student who has the sum of weights above 0.6 can be called as not good academic standing. We are just assuming this. And then we run the model, and this is the result that we have got. Overall, out of 7,000 students, we had 4,099 to be predicted right, which is around 59%. That's not a great number. Good standing, out of total 5,451, about 2,900 were predicted right, 53%. But now comes the important part, not good standing. Out of 1,548, almost 1,190 were predicted to be not good standing, which gave the accuracy of 76.8%, which really satisfied previous edition. Also, our model was built in such a way that you give the data of the students, all the columns, it will show you in one of the columns if it's good or not. And we also built it in such a way that at least 4 of the negative values should be satisfied for a student to be not, and just not the major categories like term or campus, just the gender. All of these are minor categories. Major categories should be qualified. And these are all the variables that we've selected, and we performed it on good academic standing, 3 separate sheets, one for good, one for not good, and one on a combined sheet. Although this was good in predicting the not good standing, the limitation was that the good academic standing was pretty low, which means majority of the students who were actually good were predicted to be not good. But more variables can increase the accuracy. So we also have some other variables apart from this in the correlation matrix. For example, the school or the program that student is enrolled in. So we didn't have the time to give them weights and check the sum. So I think including those variables will increase the accuracy. Time constraints, since we have only 2 weeks, the last 2 weeks to work on it, we couldn't do much on it. And these are the findings and recommendations. How else can we improve this model? What more information can maybe improve the accuracy of the model? So more variables can improve accuracy. These are some of the variables that might help in improving the model. Country of origin, this is especially in the case of international students, what country they are coming from. We might observe patterns and find the academic standard. Prerequisites for programs. Certain programs need maybe a bachelor's degree before, or it could be as simple as a written English exam that needs to be qualified to attend that program. So knowing about the prerequisites will give some information. Program difficulty level, again, we all know each program has a different difficulty level. If we are able to identify or number the program based on the difficulty level, we could improve the model better. Qualification and experience of students, financial background, change in the field of study. If a person is from, let's say, is from medical background and changes to a business background, we could identify patterns. I'm not saying it's good or bad. We could identify the pattern and then classify. And high school grades, even though we had a column that did give us the high school grades, majority of the data was missing. So very small part was available and we couldn't just use this column. After identifying the students in good or not good standing, these are some things that we could do to help them. Outreach and support for specific programs, guidance and monitoring, faculty and staff training, user feedback from both staff and students, and checking the accuracy with the new data, that is the upcoming, or maybe the historical data, to check if it has the same.
Very well done. Any questions from the group?
Good presentation. Really like how you guys like surrounded difficulty and the challenges because we know what you guys went through, like dealt with a similar thing. And it's just interesting how we can we're both dealt with these things differently, and it just kind of shows the depth of this course where the insights that you grab from this, you're able to pull even more from. It's good.
Thank you very much. So up next we have Part Niagara. They'll go at 4:10 to a couple minutes to change over.
You're right.
All right, this next project is Heart Niagara, and I'll let the team take it away.
Hi everyone. So this time around, we are navigating from the usual business case to the healthcare. So before we go deep, I would like to introduce myself on my team. Excuse me, guys. Excuse me, guys. I go by the name Michael Ishola.
I'm getting one day.
So for the purpose of this capstone project, we worked with Act Niagara. So who is Act Niagara? Act Niagara is a non-profit organization that provides health education about the possible causes of heart disease. And this non-profit organization was founded in the year 1977 by Dr. Stafford Durbin. And this organization offers different kinds of programs and services that ranges from community preparedness, looking for the elderly youth, cardiovascular diagnostic services, ASCOM, and the LD Art School program, which is the program we actually worked on for our project. So for the LD Art School program, it's actually a program they organized within the 12 municipalities of the Niagara region, whereby they go from schools to schools to sensitize children within the ages 13 and 15 on the prevalence of heart disease and how they can treat themselves, that the measures they need to take to protect themselves from heart diseases. And obviously, this program also helps students to measure their blood pressure, their cholesterol level, because whenever they go to school, they conduct survey in schools, so they help students to measure, to let them know their blood pressure level, their cholesterol level. And it's also important to take into consideration the increasing rates, the trend of heart disease worldwide. I think over the years there's been a lot of research that has been going on to understand what has been causing this increased rate of heart disease, and that have been done so far. We can say living an unhealthy lifestyle is one of the factors that contributes to the heart disease, and done so far. We can say living an unhealthy lifestyle is one of the factors that contributes to the healthy lifestyle is one of the factors that contributes to the heart disease. And when people feed on poor diets and when they don't engage in more physical activities, that we can tell from research has been done so far. But for in case of this project, our partners actually will understand what has been causing heart disease in children between the ages 13 and 15. And we did this using the power of data analytics to understand what would be the causable factors of heart disease in children. For this project, our partners were kind enough to give us data. So they gave us the data from the survey they conducted. And as you can see here, this is one page of the survey of survey questionnaire, and this is what the rest of the data looks like. And obviously, we need to put into consideration because it's working in confidential, right? So we need to ensure our partners that we keep the data safe, we didn't share it out to anybody. So we signed a non-disclosure agreement for the project. Moving forward, for this project, we utilized various tools and software. First off, we started off with Google Docs, which was used for our documentation, for our brainstorming. Obviously, before you want to start a project, you have to put something into writing on how you want to go about it. So we used Google Docs. Also, we used some of the Microsoft Office application. We used Microsoft Excel for 70% of what we did in this project, which was used for our data cleaning, and it was also used for our exploratory analysis. From the Microsoft Excel, we used Microsoft Word for our documentation and to write our reports. Also, because we needed to, we used RapidMiner actually to convert some of those variables from a non-numeric variables to a numeric variables, so as to enable us to carry out the descriptive statistics that we wanted to use. So because of deep into our findings in this project, so my team member will take over from here.
From the data we got from our partner, the total students that did the survey was 258, which are comprised of 47% of them were male, 48% of them were female, 1.6% of them were non-binary, 0.8% of them were gender fluid, and another 0.8% identified as others. The age range for this project varied from age 12 to age 17, with age 13 and 14 having the highest scores. Others then identified as Caucasian. The remaining 30 of them spread across South Asia and Africa. For this project, we had to categorize the risk factors associated with heart disease into two major parts: behavioral factors and environmental factors. We have the behavioral factors and environmental factors. I would love to run you through the major medical terms we use for this project. Diabetes is a chronic, the major medical terms we use for this project. Diabetes is a chronic and metabolic disease characterized by elevated level of heart failure or heart attack. Hyperlipidemia, also known as having high cholesterol. When you have high cholesterol in your blood, it will be very difficult for blood to flow through your arteries, and this will also cause stroke or hypertension, high blood pressure. It's when the pressure in the blood vessel is very high. This is also a factor. Family history. Having a family health history of diabetes makes you more likely to develop heart attack or heart disease. Because we get half of our genes from our parents, we get 50% of the genes from the father, and other 50% from the mother. So if any of the parents have like the medical factors, it's going to be passed on to the offspring. For our visuals, the data given to us in the survey, it shows that a very high percentage of students said no to any of the family members having any of the biological factors. Going by the student wellness, BMI. BMI is the body mass index. To get your BMI, you have to divide the weight divide the height. Yeah. 8% of the student had normal body weight. 24% of them were underweight, and 12.1% of them were overweight. Just 4% of them are obese. For the blood pressure, and very low percentage had the abnormal. From the survey, there was 4 students with diagnosis of diabetes, another 3 of them diagnosed of hypertension. From the questionnaire in the survey, they wanted to know if students were aware of potential risks of taking vape and cannabis. The majority of them answered yes to this because they are aware of the potential risks taking vape or cannabis can cause to them. Them answered yes to this because they are aware of the potential risks taking vape or cannabis can cause to their health. My we have the nutrition, activity, and the sleep pattern. I'll start off with the nutrition. So Mediterranean diet and nutrition preference. Mediterranean diet is a traditional cuisine of countries bordering the Mediterranean Sea. Just to break it down for some of us that don't have the knowledge or idea what the Mediterranean diet is, it's simply the high consumption of vegetables, fruits, nuts, grains, and protein. And from our findings, which vegetable times, fruits at least 2 to 6 times, and fatty at the high percentage. The same goes for the whole grain. So we can classify whole grain as rice, pastas, bread, and they also take whole grains 4 times or more per week. Now for nutrition preference, we can see that a lot of students, and this is a very good approach for students on this stage, because having a healthy dietary plan can benefit the overall health of students, but having little or having lack of essential nutrients in your diet is actually, or it can increase the. So moving on to the activity, bus or car, playing with friends, visiting parks, or going shopping with family. So we can see from our findings that the students are active during the week with an average of 7.5 hours. They are inactive with an average of students active during the week with an average of 7.5 hours. They are inactive with an average of 8.5 hours, of 16.5 hours. Weekend, that is from Friday to the activity part was classified. And for the weekend, they are inactive, that are for an average of 6.5 hours. That of the weekdays have early good sleep, which may be because they go to school, they need to get up early to get ready for school. Weekends, they are more relaxed, and just like school, they need to get up early to get ready for school. Weekends, they are more relaxed, and just like weekends. So, my colleague here to take us to the conclusion.
Thank you very much. Here I'm going to present it to some correlation we did for a trainer, since our data was yes or no information, so we had to transform it to numerical and then export to Excel in order to do the correlation. So we found some positive correlation in those groups. For example, obesity. We found that people or children that are obese are most likely to have hyperlipidemia, hypertension, and diabetes in the future. And we found that if smoke-free, they are most likely to smoke in the future or smoke sometimes, and people who have their family story, family members who has like this story in diabetes, hyperlipidemia, and hypertension, they are most likely as well to have these diseases in the future that can. So moving now to the conclusion, I'm not going to repeat or to give all the numbers my workers already mentioned, but I just want to highlight and recall that our data were to have these diseases in the future that can cause heart disease. So moving now to the conclusion, I'm not going to repeat or to give all the numbers my co-workers already mentioned, but I just want to highlight and recall that our data was basically within 13 and 14 years old nutrition, even if we don't eat most grain and meat and fish. We don't really know why, but this is what we found in the data. And they overall have a good sleep during weekends, that is good. They have a good BMI, that is good as well. And now we move to the project communication. mentioned before, our data was a little bit because that is good. They have a good PMI that is good as well. And now we move to the project communication. So as mentioned before, our data was um, a little bit messy. Forgive me for the word. Mostly in the nutrition activity and sleeping part, we miss many information in the smoking part as well. So we need it, and we have the time limitation. I know this is the same for everyone here because while taking the courses, exam, time limitation, I know this is the same for everyone here because while taking the courses, exam, family life, work, and even this project, it was so challenging. And the survey conviction, work, and even this project, it was so challenging. And the survey conviction, the survey that we thought that it may be most categorized because, for example, in the nutrition part, they are so wide in this part and many information that could be categorized to help us to do a better. In terms of recommendation, we recommend, for example, in the future to have a simple method selection, have a master organized data because there were many different things, and have more structures survey because what was a little bit challenging in this survey is that we have the parent who has to answer the question and the students. And if we take, for example, the smoking part, if I'm a student and you ask me if I smoke and I do smoke, and I know that I have to give this same shit to my mom, maybe I will say that I don't smoke. As well, for example, in the nutrition part, if you ask me, even at my age, I'm 30, if you ask me how many ounce or pounds or gram I, for example, to the mom, who can more or less, or we wanted to make like a modelization, but since we had many missing data, we were not able to build a model, but this is the analysis we wanted to present to you. So thank you very much. Thank you to our professors. Thank you to our classmates. Thank you to our staff.
Very well done. Any questions for this group?
Really good job. I remember seeing that and how deep it was. I understand entirely the difficulty and challenge that you guys had. And so really good job. Even your dashboards are great. It's clear you guys knew your time. Came through really well.
How many rows? Or sorry.
And we had at least 359 columns, but 121 duplicates. 121 duplicates.
And for clarity's sake, there were some parts that had responses, and there was some part that didn't have any response. And as an analyst, it's like you can't, because a part has a response, we decide to ignore, and some parts doesn't have a response, because we at some point we discovered that area where we can actually do our analysis are where, you see, for example, students fill information about their activities during the week, and when it gets to the hours they sleep or during the weekend, they omit that part. So it makes it difficult to more like do our correlation to know, okay, this is the additional hours they sleep, this is the additional hours they are active. So, but with the support of everyone in the team, we're able to come up with something and achieve what we've done so far. That's great.
Any other questions? Thank you very much. So we have our final presentation now, crime in Toronto. Whenever you're ready.
My name is Jagmeet.
Myself, Jeslo.
I'm Trintas.
According, according to Toronto police report, there are crime increasing day by day in the Toronto area. So in this project, we are going to talk about the crime rate rising in the Toronto from the 2014 to 2022, and also we will talk about the what are the factors responsible behind the crime rate increasing in Toronto area.
The open source report was collected on the website of the police and that. One thing is that the manual is authentic data and it is very anyone can verify the data on their own anytime. And then when we collect data, it has 36,107 euros and 81 dollars. That shows you how big, how heavy, and massive the data was. And then next time, then the tools we used was MATLAB and then Power BI and R. Like I said, was used to perform the analysis, then I was used to clean the data, and that was used to for visualization. You know that it's interactive, very easy to read by anyone, and very good accurate. So these are our analysis and patterns. So the first type of analysis we did was total crime analysis. So like I said in my previous presentation, that when the crime is committed, it's committed by an individual or a team of individuals, and it's committed in a certain location and in certain places. So we have seven type of places that are committed every day, every month, every year, and every hour. We have the apartments, the commercial premises, we have the school premises or the premises, we have the house premises, we have other premises. These are church premises, mosque premises, the nursing homes, and so on. Then outside premises, these are open areas like the highways, the streets, the beach fronts, the roads. So any open area you see is outside area. And transit is maybe the bus station, train station, and the rest. So from 2020 to 2022, so you see that the premises time with the highest crime rate is outside areas. The open areas like the transit, the highways, the street, the lakeshore, the beach front. So they have they have the crimes, and then followed by apartments. These are condo houses. So for instance, now in year 2022, more than 10,000 people are committed in outside areas, followed by apartments. And then the least premises, the least type of premises where crimes are committed is the top premises, like the colleges, universities, the primary schools, secondary schools,
and any academic area, then followed by classes. So because in colleges, so no one is expected to commit a crime in the school premises or in the elementary schools. And then transit areas like the road station, so crimes are limited in these areas. So the next, so the next one, crime by hour. From the chart, it tells us most of the crime interesting from the midnight, the more crime happened in midnight, around 12 midnight, and then degrees. Come to morning 6, maybe after the crime they're gonna get rest, sleep. So after taking rest, and then another break, and then noon. That's interesting. By week, there's not much huge difference, but by week, there's like a Friday and Saturday because of that weekend. So if we combine this one and this one, we can say now maybe like a Friday, like a midnight. Then the people get a drink, go to the bar, and then the more people outside. So more crime happens by weekend, like on midnight. This is by month. It's not like a huge difference. If you look at like a slight decrease from the January, February, because of the weather problem condition. Because of this month is cold. The weather is cold in this winter time, so maybe less people. It's less people go outside coming home. And then when we reach to like a summertime, it's increase.
We see the total crime by the year. We can see from 2014 to 2019, it was increased at a high pace, but in the COVID time it decreased. And after the 2021, it increased like very rapidly. We can see in 2021 it was almost equal to 2040, and in 2022 it reached equal to 2019. So maybe there is many factors due to pandemic. Some people are becoming poor, or maybe there many reasons they become criminal, or they started doing assault and other type of crimes. Crime indicators by hours, when we categorize different type of crimes by hours, I found that crimes are same like at least per hour total crime. They are highest in the midnight and the afternoon. And after the afternoon, they start decreasing once and then going up again. Crime indicators by week, when I saw by weekly, when I categorized, I found that the assaults was maximum in the Saturday and Sundays, while auto theft is high on Wednesdays and Tuesdays, but robbery is highest on Friday. After that, when I analyzed them by monthly, I found that the assault is highest in July and August, but auto theft is highest before winters in October and November. Maybe criminals need car for winters, we can say. But break and robbery is almost same all around the year.
So in this, we are talking about the indicator by year in each year from 2014 to 2022, as you see over here. About the indicator by year in each year from 2014 to 2022, as you see over here. This mainly we talk about the five crimes. which is assault, auto theft, pregnant robbery, and theft over. If you can see, there's a pattern in the crimes that's been seen here. Like in 2019, there's a great increasing every crime over here, and starting 2020, there's a great decrease due to COVID. As far as COVID had a great impact in every of our social lives, including even the criminals, like they also went down. And after that, all kind of theft. But there's slight difference in the auto theft. Here in the 2020, there was a great increase. 2022, 2025 by location in the surrounded area. As you see, like to suburban areas, outside areas, such as the Old East Shore and Parkland Wood, it's decreasing. And next, it's the map. Here, the urban area made downtown area. The crimes are too huge and too much crowded, like too much because they have big city, happening place in the area. Some of the areas like very less, and there's a crimes like remote areas. And the crimes, there's a specific area, even though it's crowded area, these are not specific, like no location. So the crimes such as some like cyber crimes, blackmailing, extra, like the crimes that happen in cyber world, and crimes it's not registered, such as if there's an issue with the two lands or something like that, they will be coming under not specified area. It's also there's a huge decline in year 2022 or 2020. There's a steady increase after that.
So with over 17,000 assault crimes and almost 10,000 theft crimes reported in Toronto in only 2022, we wanted to find out what was happening in this neighborhood. We wanted to find out what made up this neighborhood. Why is it that some neighborhoods have a higher crime while others have low crime? So we wanted to know the demography of the neighborhood. So we have to collect more data from the City of Toronto website, toronto.ca, and we're able to make this visualization on Power BI. So there are over 100 neighborhoods, so I didn't want to have you looking at so much. So I just brought out 2 neighborhoods with high crime and 2 neighborhoods with low crime to explain what we have. So the age, yes, they have the youth, the working, the children, and 65. We see that there are more people within the working age, which is 25 to 54, and it's the same for both neighborhoods with really high crime and really low crime. We also have things like the immigration, immigrants and non-immigrants, and then the household income. I was able to understand this household income using the Pareto principle that states that a small percentage of the resources is being shared amongst a larger number of the population. And then we have the workforce by neighborhood, those in the workforce and those that are not in the labor force rather. We see that there are more people in the labor force than not. And also the marital status by neighborhood, we see that more people are living under common law and not married in really high crime areas than not. And then we also have the education by neighborhood, where we see more people in the high crime areas that have bachelor's degree and those that have no degree.
Okay, so after the, at the beginning, when we started the project, our initial, we were so ambitious. At the beginning, we want to have the major crime indicator data set from the because the result we we talked about that earlier. So our initial purpose was finding or figure out what caused this crime increase. So for this analysis, our major crime indicator data set, they went from like a 2014 to 2022. But neighborhood data is like based on the census 2021. So 2021 is based on the like from the so 2021 is based on the like from the 2016 to what we did, we didn't use all the data from 2014 to 2022. That's better, from the also same thing for 2016 to 2020. These are correlation analysis was all. So these are correlation analysis was all the characteristics of the base neighborhoods. But the final, we come to this renter, immigrants, refugees, like they looks like they have like a strong correlation with crime. So so at this stage, can we make a there's a higher crime because of the refugees? No, we cannot say that. So right, because of the refugees? No, we cannot say that. So correlation. So if you look at this, like a crime prevention in Ontario, they have this kind of research. So basically, they figure out the risk factors. What is the risk factors? Risk factors like a negative characteristics, like for example, in individuals or in families or communities. So if you back to that previous slide, so we have the low income. Maybe here, if you look at here, we have some like a poverty risk factors. So we don't have much more information in our data set with information related to these factors. So in that case, we are unable to make a decision saying that these are risk factors. In that case, we are unable to make a decision saying that these are risk factors. A decision saying that these are risk factors are responsible for this increase of the crime in this neighborhoods. So. And then for the further research and the recommendation, like this is kind of like a social research, we suggest that before doing this kind of research, by doing this, we by other people. So then we get some idea, or we will have some like ways or data. We can use the secondary data as secondary data information. And then we can focus on what we can do more. So for the recommendation, we list the three sections. The first one, the literature review, then find out more data set information, which reflect that can summarize the risk factors, such as drug use, mental health, poverty, and more. Then, based on this data sets, then conduct deep crime increase. That's our recommendation. Thank you.
Sure. Any questions for this final team?
Just good job topping up all that data. Like it was very impressive to see even like the timestamps of when crime was happening and the changes. Because even being a Niagara resident, over the past few years, we know that there are, say, more break-ins or arrests that do happen at lunchtime, where you think it only happens at night, where sure you're looking at Toronto data, but you can see the parallels, the changes happening to us here, and how it's all correlated. We'd be able to see the future. But you guys did an excellent job of cutting up all that information and presenting in a way that, as non-criminals, it's very interesting to see. Very true, yeah.
Because we got this data from the open data source, both data from the open data source. One is from Toronto Police Services open data source, and the second that we got the data from the Toronto open data source. So there's not ethical data.
And what about the conclusions that the information you can lead to you? You don't think that might be also an ethical concern for you, or maybe concluding that people with this characteristic or others might be criminals?
So that's what he said. We're not making any conclusions. We're not making any conclusions. We're just like showing the correlation between different variables. We need more analysis to make any conclusions.
It's hard to say, some group are, committing crime more than compared to the other group. It's not logic. So we just want the analysis, correlation analysis. Even it is like a regression analysis. But finally, we just give up. It's nonsense. It's not the what is it dependent on the variables. As I say, like age. The dependent on the variables. As I say, like age. The refugee. It says, the immigration. Using this attributes to this.
Like the time of the day when time happens and so on. But like my question is like from all the things that you show, like what are like the main insights or findings that you got? Like for example, think about like what one Wright said to us in class. Sorry if I'm looking for reference. One day he was like, okay, if you have like to talk to the president of the company and you have to give like 3 insights like of the sorry if I'm looking at the reference. One day he was like, okay, if you have like to talk to the president of the company and you have to give like 3 insights like of the all pieces that you've done. All these like insights or findings. Just the 3.
Most crime committed is assault. From the, I think this slide was this slide. So assault is the local crime. And this one is, I think, things for that. This communication. So these are things that we need to research. Then the pathways and the prejudice type, the locations, the master places, and then this ways for locating. That's the
I am like the chief of the police of Toronto. Like, what would you advise me to do? Try to find.
Just to be careful with your movement. And then, just anything. Just
Other than that, when I saw crimes are very less in November and February, but there is still little increase in December and January.
Any other questions? Thank you very much. Thank you. That's everybody, right? That wraps up the presentation. So thank you very much. It's been a great 8 months. I'll still see you on Thursday, but other than that, have a great night. You've worked very hard and enjoy the rest of the day. Woo-hoo. Done. Done. All done. Yeah.